We love coming here to SC every year because it's a great opportunity for us to show the server platforms we've been hard at work developing for a number of markets. We got platforms targeting the core data center, application web server type programs. Also, we have a number of high performance computing platforms designed for artificial intelligence, HPC, deep neural networks, and all kinds of new and fun emerging stuff. So most of our new platforms, in fact, everything we've launched over the past year has been based off one of two things, either MGX platforms for GPU and AI servers, and the other is a technology known as DCMHS, Data Center Modular Hardware Systems. It's a specification that came out of the OCP, Open Compute Foundation, over the past couple of years. We're really excited about DCMHS Architecture because it presents a building block approach for server design. So it disaggregates the BMC and the entire control plane of the motherboard off of the motherboard and onto a separate card called a DCSCM, a Data Center Secure Control Module. And what that does is it helps disaggregate the management from the processor, and it takes the motherboard and breaks it into a secure control module and a host processor module. It does two things. Primarily, it standardizes some of the shapes we've been using in the industry for a long time. It standardizes the motherboard sizes. It lets us reuse chassis across different CPU types, different architectures, and also generations. And the other is by taking the BMC off the motherboard and putting onto the DCSCM, it allows us to standardize the BMC design across CPU types and across server types, which if you're doing OpenBMC firmware development, it helps simplify your code base quite a bit. But also there's some emerging technologies across things like TPM, your Trusted Platform Module, your Hard Root of Trust, the ROT. We have to pick a device for secure hardware security, and we've done the AST 1060 in our platforms, but if you have a certain hardware requirements that doesn't match, in the past with the traditional architecture, you would have to do a custom motherboard to put a different ROT on the board. But by disaggregating things, we can modify the secure control module, put a different ROT on it, for example. Now, just by virtue of our modular building block approach, that's applied across our entire roadmap. So the building block approach really simplifies designs from our side as the server designer, but also on the customer side because it reduces the testing and validation you have to do. You swap the processor out for a different type and you get to reuse your chassis, you get to reuse your SCM, you get to reuse your BMC architecture. So we're really excited for the flexibility this architecture brings, and we've used it across the board here at MSI. So one of the main things we've used this DCMHS architecture on, we have used it across the board everywhere, but one of the places where I'm most excited about is the line we call MSI Core Compute. If you look at one of the highest volume, the most important server types in the data center, they're your compute nodes, things for your front-end web servers, your application servers, VM hosts, things like that. What is it? Is this just a bunch of cores in a rack? And so customers are trying to find the cheapest way to deploy as many cores per rack possible. So we designed, a platform that we call Core Compute. It's a set of chassis, a 2U4 node and a 2U2 node that are designed for compute nodes. So you're not getting a ton of I/O, you're not getting a ton of expansion because that's not important for this segment. It's got front I/O design, it's got single sockets, so you don't have to worry about performance optimization, you don't have to worry about NUMA penalties, and you don't have to worry about pinning threads to a certain socket. By virtue of one socket, if you have one processor, everything's attached to the same sockets. There's less optimization tasks you have to do. They're easier to cool because there's one processor, and we can support things like 500-watt processors. So by having two chassis options, the 2U4 node is great if you're using a low-power processor. Some of the E-core designs from Intel or AMD, those things come in around 250 watts or below. The 2U4 node is still great for that. Our system is designed around something called an EVAC heatsink, EVAC, Extended Volume Air Cooling. Basically, it's a fancy term, just a massive air cooler. What this does is it drives down the fan power consumption, so the fans don't have to work as hard, and also increases the given TDP that we can support for any given ambient temperature. So our 2U4 node is great for lower power processors, but if you want to push 500 watts, maybe higher in the future, our 2U2 node platform is designed for this. It's got a massive 2U EVAC heatsink. Not only does it sit on the keep-in zone of the processor, but it expands with heat pipes to remote fin stacks. So we're actually able to air-cool 500-watt processors today. We even have some off-roadmap SKUs of these platforms where we remove things like drive bays to enhance the airflow capabilities. So we've seen some of these systems air-cool 500-watt processors with less than 20 watts of fan power per node. So extreme efficiency, and the efficiency lets you drive density too, because the less power you're spending on cooling the system, the more power budget your rack has. You can actually fit more nodes in the rack, more cores in the rack, so you can actually deploy in less racks. You need less racks, less top-of-rack switches, less infrastructure. So density is good for everything, and that's what our core compute platforms are really optimized for. So we've talked about DCMHS. DCMHS has been a foundational building block for our general purpose core data center server types. The DCMHS design is great for things like your application servers, web servers, things that use OCP NICs and things like that. What we found is it's not great for GPU servers and AI, so there has been a new derivative kind of based off of DCMHS that has been known as NVIDIA MGX. It takes a lot of the core tenets and philosophies of the DCMHS building block approach, and it kind of tailors it to the strengths of an AI server. What does this mean? You're not wasting lanes on things like OCP NICs. You don't have an external DCSEM. It's more internal, so you can cable everything out to the GPUs. And for what this means for our server design, MGX systems let us do really high capability platforms for AI for GPU servers. We can do for example, we have a 4U MGX chassis that has support for what NVIDIA considers a 285 configuration. 2 CPUs, 8 GPUs, and 5 NICs. And 5 sounds like a weird number for network cards, but it makes sense. You've got 4 cards for your east-west communication for clustering, and NIC number 5, that's your data fabric NIC for your data network. But it's just an example of what the MGX architecture lets us do. And so we've got a platform now based off of the current generation Intel Xeon platform for NVIDIA GPUs. But because it is a building block approach, we can reuse that chassis design and mix and match the different processor types going into the future. So MGX is the foundation we're building on for the future of GPU and AI servers. So MSI has been around for a long time, and a lot of people are going to be familiar with the MSI brand as more of a consumer hardware brand. We've spent a lot of time making laptops, desktop PCs, graphics cards, and things like that. MSI has been in the server industry, in the server space for more than 20 years, dating back to 2001, MSI Enterprise Platform Solutions, which is who we're here with today. MSI EPS has been around since 2001, and it's been in the more custom hardware, the ODM server space, where the customer comes to us with an RFP, and we do a custom hardware for their custom projects. Going forward, MSI EPS has been focused more on a off-the-shelf channel approach. So all the platforms we'll be looking at today are things that we're going to be building to inventory and have for general availability. And so MSI has been investing heavily within the server space for the past year, and you can see behind me and around me as we take a look around the booth just the fruits of that endeavor. We've more than doubled our R&D headcount for the past year, and we've also invested pretty heavily in local resources in North America. So over the course of 2024, the past year, we've added an office to Fremont, California. We've added local field application engineering, local technical support, local inside sales, account managers. We're also bringing up server integration this year, and over the next year, we're going to be expanding it to rack integration. All the server platforms we showed today, they're all available as bare-bones systems. We're not forcing fully integrated servers on customers, but for the customers who value that as something that they're interested in, we do have the capacity to support that going forward. So MSI has been the gaming brand that you all know and love, but we are investing in heavily into the server space, and I hope some of these products catch your eye today, because I'm excited about a bunch of these.